So let me, some of you may forget about these lines. Yeah. So it's a server-side scripting language. Yeah. So we write programs at the server side. Yeah. And we need to do communication between client and server. Yeah. Okay, yeah, all right. So here, there is one important thing I want to point it out. Yeah. I didn't mention last time, yeah, so let me point it out. Since this class is a database class, yeah, so we, the core part, so the database part. Yeah. So other things, just related to the database. Yeah. So when you do the PHP programming, you need to work with the database. Right? So here, one thing I want to point out, a very important thing is, when we work with databases, we know, because we do client-server programming, right? So you have a client side, you need to write some programs. And the server side, you also write some programs. So we need to look at both sides, client side and the server side. Then there is an important, basic important problem you need to consider. That is, at the client side, never access databases. Never access databases. One thing, okay? Never access DBs. Reason is simple, for security reason, okay? Client side, we know client side, yeah. A lot of code, client side, exposed to the user's machine, okay? Yeah. So if you access the databases from client side, it's not very good to protect your database information. Yeah. So at a client side, we never want to access the databases, even if we have that capability to access. Yeah. In JavaScript, there is a way to access databases from JavaScript. JavaScript has the capability to connect to databases at the server side. It has that capability, but never do it for security reason. Okay? For security reason. Yeah. So then, now you know. So we only access databases from the server side. Yeah. So this side, yes. Okay? Okay. Yeah. It's a good way. Yeah. Server side. So we can do good data protection. Okay? Yeah. Security, data security problem. Yeah. So that's one basic question. Okay. All right. So then, to use PHP, we write a code, PHP, use this code, embed PHP code inside HTML. Okay? So we start with a HTML file. When we start, usually we start a HTML page. Then we know the HTML pages can only deal with static content. The static content, HTML content. This part, static. Static, okay. Never changes. Yeah. It does not change. Static content. Yeah. But to make your web applications more useful, you need to work on the dynamic content. Okay? Yeah. Because when the users do some interactions with your applications, so you need to provide appropriate feedback, response, data, So that's the dynamic part. Okay? Yeah. So do the dynamic content, you can do both from client side, server side. Client side, JavaScript. Yeah. JavaScript. Then at the server side, you also need to do the dynamic content. Yeah. The two sides. Yeah. All right, so here, at the server side, you use this PHP tags. Yeah. So you can embed PHP code anywhere in your web pages using PHP tags. Yeah, pretty straightforward. Pretty straightforward. Okay. Next, I explain the internal processing related to PHP. The internal. Okay. How does the server process the PHP files? Yeah. All right. Yeah. So, oh, sorry, I need to connect my remote control. Yeah. All right. Yeah. All right. How to execute PHP code. Yeah. All right. So, suppose our PHP program is ready. So we have several PHP programs at the server side. Now we want to run. Yeah. So when we start, the starting point, how to call, how to access your PHP files. Yeah. We start from the server side, the web browser. Yeah. All right. Yeah. So here, yeah. So I said call the engine. So here already. So when we start, yeah. How to call PHP files. Okay. Yeah. The starting point is user type some URL, user start some action at the browser, web browser, okay? Either type URLs or click buttons, links, do some actions at the client side. So then, because when you do some actions at the client side, you send URLs to the server side. You send URLs containing, so in the URLs, the PHP programs, so the PHP program, the file names of the PHP programs included in the URL. Included in the URL, okay? Yeah, so URL. At the end, you need to add PHP program, file name, okay? File name. Yeah. In that way, you call a PHP program at the server side. Okay? All right. Yeah. Then, another important thing. Yeah. Because that URL is sent to a web server. Here, Apache, we use Apache web server. Okay? Apache web Yeah, last time I said the full name is Apache Web HTTP server. Okay? Yeah. HTTP. Yeah. So that protocol, I will explain HTTP protocol in supplementary videos. Okay? Supplementary videos. Yeah. Not here in class. Yeah. All right. So after Apache Web HTTP server receives the URLs sent from the client side, so it needs to do processing. Okay. How does it do processing? Okay. Yeah. First, Apache server needs to know this is a PHP file. Okay. Need to know that. Yeah. Yeah. Because the user may send other type of files, right? HTML file, other files, PDF file, okay, image files. The user may request other files, not necessarily PHP. So the first thing the server needs to do is detect if the file is a PHP file. How to detect? Use the file extension to detect. So we know the PHP file, okay, yeah, here. PHP file, we must use the .php extension. In the file name, you need to use some file name .php extension to tell the server this is a PHP file. If you do not use PHP extension, then the Apache server won't treat it as a PHP file. Okay? Apache server treat it as some other types file, and if it's not a PHP file, the server won't send it to PHP engine. Yeah, because only the PHP engine that is connected to the Apache server can process the PHP files. So it won't send it to the PHP engine. Yeah, so that's one thing. Yeah. So then, if it sees the PHP file, then send it to PHP engine for the processing. Yeah. How does the PHP engine do the processing? Yeah. So very, very simple. Yeah. So the engine goes through all the lines inside the PHP file and interpret. Yeah, here. The engine uses the interpret way, yeah, not compiled way. Yeah. Interpret and execute. Yeah. So you know the meaning, right? The interpretation, execution. Yeah. So not compilation, yeah, interpretation. Okay, yeah. But the engine only processes those lines inside the PHP tags, not HTML. HTML lines, the PHP engine bypasses all the HTML lines, all the non-PHP lines. Non-PHP lines, so the engine just skip all those lines, only do the processing inside PHP tags. How to do processing in the interpretation way? So you know interpretation way. So then execution. Yeah. So you have machine code. Yeah. So all through interpretation, not compilation. Yeah. So then execution. Yeah. Yeah. So execution. Yeah. Because the result of the execution, your PHP code may generate some output result. Yeah. Sometimes you do processing, but sometimes you produce some output result. The output result usually should be the HTML content. Yeah. HTML content. Yeah. Because you know eventually the processing result will be returned to the users. The users will use the web browsers to view the processing result. Okay? So usually, most of the time, it's the PHP content. Yeah. But in some special cases, could be other content, other files. It's possible. Yeah. Here, at this point, we just consider the most common case. Yeah. Produces, that PHP program produces HTML content. Okay? Yeah. Yeah. So then this PHP engine sends the generated HTML content back to Apache server, as the processing result. Yeah. So the Apache server returns the result generated by PHP engine and send it back to the client. Yeah. The client. Okay? Yeah. So send it back to the client web browser. Yeah, here, client web browser. So then, at the client side, the user can see the result page. Result page. Yeah. So that's the whole procedure. Okay? Yeah. So how to execute a PHP program. So with this background, yeah. So after you have this understanding about the basic process, PHP processing picture, so then when you write your PHP programs, you know what happened behind the scene. Okay? Yeah, very natural. Yeah, very natural. Okay? Yeah. All right. Yeah. Then, next slide. Yeah. Yeah. Execute PHP files in server. Yeah. Some more information. Some more detailed information. How does Apache process a PHP file? Yeah. So we mentioned a little bit. Yeah. So first, PHP file must use .php extension. Yeah. So we mentioned that. Okay. After Apache detects PHP file, it passes to the PHP engine for processing. Okay. I talked about that. So PHP engine bypasses HTML content, only process PHP code and returns result as HTML content to Apache. Yeah. So in that diagram, I explained that. Yeah. So here you treat it as a summary, okay? Summary, so from the previous page. Yeah. So then Apache returns HTML response to the client. Okay. Yeah. So the browser at the client side renders HTML content. Yeah. All right. Yeah. Database properties. Yeah. Some more information. Yeah. Universe of discourse, UOD. Just some terminology. Okay? Yeah. Remember, when we design our databases, we use them, work for our business. So there is a business. So a lot of detail about the business. We want to reflect the important aspects in our business, in our database design. Okay? So the business part that we are interested in this project. Yeah. Let's assume we have a business project. Okay? Yeah. So that part, we're only interested in that part. Okay? Not the whole world. The whole world is too big. Okay? But we're only interested in a small portion of the world. So that part, our business, our databases worked for that. So we give a terminology. Here, this universe of discourse, or another term we call it mini world. So it's a part of the world, mini world, mini world. Okay? Yeah. So, yeah. All right. Represents some aspects of the real world that our business project is interested in. Okay? Yeah. So that part. Terminology. Yeah. Yeah. Here, even in the mini world, we know even in the mini world, there is a lot of details in the mini world, right? Yeah. But in your database design, even in the mini world, you do not represent everything in the mini world. Okay? A lot of detailed information you want to ignore. So ignore a lot of unrelated details in the mini world. So only the useful, only the information that is useful in your business. Okay? Then you need to represent in your databases. Basic design. Okay? Yeah. 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 It could happen like this. At the beginning, something you feel not useful. Okay? So we can ignore. Yeah. But later, so when you get a better understanding of your business, then you feel, oh, so that information, that details you skip before, actually it's useful. So you want to represent it. Yeah. So that could happen. That could happen. Okay? Yeah. So you keep doing the adjustment, yeah, to make your databases to reflect the minimum appropriate way. Yeah. All right. Data representations directly reflect the states of the minimal. States. Yeah. So here we use this term, states. Yeah. Because when we use the states of data, yeah, because the data keeps changing with respect to the timeline. Okay? Yeah. So every time, every point in the timeline, the data keeps changing. Okay? So at every instance, there is a state. Okay? So the state of the data in your databases keeps changing. Yeah. So your understanding is like that. Yeah. So you need to manage your databases covering, all the states. Okay? Yeah. 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 So you should have this understanding. The data keeps changing. Okay? Yeah. All right. Coherent. So another property for your database. Coherent. So the data, your business data should be coherent. Yeah. So what's that? Coherent. Yeah. So we know most of the data, when you use to represent the real world business details, lot of hidden meanings, right? A lot of hidden meanings. Yeah. So based on our real world experience, so a lot of data has hidden meaning. Okay? Yeah. So the hidden meaning based on our everyday life. The data has some logic following our everyday life experience. Logic. Yeah. So in our data, that hidden logic, usually we do not represent hidden logic. Okay? Yeah. Yeah. For example, the family members, right? So when we store data about family members, so a lot of relationship about family members, that relation we do not need to do anything in our database, right? Yeah, because that relationship, we assume, everybody knows that. Yeah, yeah. And all the assumptions we use should match our real world life experience. So those things hidden, yeah, but we require that, so that's why we have this coherent requirement property. Okay? Should be coherent. Okay? Yeah. So you should not have the data that contradicts our real world life experience, right? Yeah, something ridiculous. Okay? Yeah. A male, female, right? Teenager, yeah. No contradiction with those concepts. Okay? Yeah. Yeah. Because son, daughter, sex, for example, okay? In our dependent table. So we have a dependent table. Okay? We have employee table. We have dependent table. Okay? In employee table, we have, sex field, male, female. Okay? Sex field, male, female. Yeah. Dependent table, we have son, we have daughter. Okay? Dependent table. Okay? Yeah. Coherent means, because it's impossible to store all the details, right? And a lot of things redundant. Yeah. But it should be coherent. Yeah. you know, the sex of son should be male, sex of daughter should be female. So that kind of information we do not store in our tables. Yeah. But when we do the queries, we should have that. Okay. So you cannot have any violation about that. The hidden rules, okay? Hidden rules. Yeah. That's the meaning here about this coherent requirement. Okay? So the data should be coherent. All right? Yeah. Logically coherent with some inherent meaning. Yeah. Yeah. But people do not describe all these inherent meanings. Yeah. Redundant, right? So if you describe it, the information is overwhelming, yeah, but redundant. So why you do that? Everybody knows that, right? So redundant, okay? Yeah, yeah. All right. But you do not allow any contradiction, okay? Yeah. So in your data queries, yeah, you do not allow any contradiction. Okay? You should maintain coherence, okay? Yeah. All right. Support the business in a right way. Yeah. Another requirement. Yeah. So your data should support the business in a right way. Here, we only talk about the general principle, how to support in a right way. Then, you need to do a lot of work the right way. Okay? It's hard to describe here in general, right? Yeah. Because we don't know your business. What is your business? We don't understand your business. Okay? So we cannot talk about the details of your business. Yeah. Yeah. So here, yeah. So you should make your databases support the business in the right way. Yeah. If in the wrong way, sooner or later, you will get some trouble. Okay? You will get some trouble. So you have to fix the problems. Yeah. After you fix all the problems, then you get the right way. All right. Specific purpose. So the databases, you use them, work for specific purpose, not general purpose, specific regarding your business. Okay? Your business is very special. It's different from other people's business. So your databases should have specific purpose. Yeah. All right. So provide valuable services for a certain group. Yeah. Okay. Yeah. So here the general description, the overall picture about your databases. Yeah. All right. Yeah. So that's the some high level overview about the databases. Yeah. Later, so we try to understand more information, going deeper and deeper inside the databases. Yeah. Okay. Yeah. All right. C.3, Database Management System, DBMS. Now let's look at some basic concepts in DBMS. Yeah. All right. DBMS, a collection of programs managing databases. So the title, you can treat it as a description of the DBMS. Yeah. It's a collection of programs, okay? Yeah. Managing databases. Yeah. So let's look at the properties of DBMS. An interface it provides. So DBMS, okay, the first property. So it needs to provide an interface between databases and end users. To work with databases, the end users need to use certain interface. End users. So what are end users? There are many groups of end users. Business people, end users, programmers, end users, right? And customers, end users, you can think about. Yeah. So customers actually the users of your web applications. Yeah. Yeah. Through. Yeah. So not directly work on databases, indirectly, customers. Yeah. So the business people and IT people, yeah, programmers, many different groups, they need to use the databases. Yeah. All right. So here there are two different interfaces for these two groups, several groups. Yeah. So more than two, several groups. Yeah. Yeah. But that number is not that important. Yeah. Certain number of groups. Yeah. The specific number may not be that important. Okay. All right. First, programming interface. Now you understand, we as programmers, yeah, so here we assume most of us, it may not be 100%, most of us, we treat ourselves as programmers, so database programmers, okay? So we need to use programming interface. When you write a code, how do you do the queries? So you need a programming interface, to allow you to send SQL commands to the DBMS, okay, through programming interface. Yeah. But different programming languages have different programming interfaces, right? So Java has Java's programming interface. PHP has PHP's programming interface, and so on. Yeah. Yeah. Another one, administration interface, because there is another group also very important in business, not programmers. Okay, so we do not treat them as programmers. Yeah. But they work on databases every day. Yeah. So we call it DBA, yeah. Database administration people. Okay? So they work on DBMS using the SQL commands, work in the DBMS environment every day. DBA people. Okay? So they use the administration interface. It's different from programmers interface. Okay? So, yeah. So that, another important interface. Yeah. All right. Yeah. Manage. So when we talk about managing databases, so manage the meaning create databases. Yeah. The basic things, the managing part. First, you need to create new databases. Then read data, query, read data, retrieve, read data, read, retrieve, okay? Yeah. Based on the business requirements, so you read the data, retrieve, yeah. All right. Then update. Yeah. So you modify your data, update. Yeah. Another basic action. Yeah. Then delete data. So these four basic operations for managing your business data. Yeah. So usually people use the initials of these four words. Yeah. CRUD. C-R-U-D. Okay? Yeah. So in many in many database-related articles, so when you read technical articles related to databases, yeah, so most authors, so they use, this CRUD, okay? The CRUD operations. So when you see that, refers to these four basic operations. Yeah. Yeah. Okay? Yeah. Yeah. But one thing I want to mention now, yeah, because from previous lecture, we also learned some basic operations. Remember, it also 4 basic operations: retrieval, insertion, update, and deletion. Yeah. The second one, insertion, insert data. Here we do not see insert here. Okay? CRUD. Okay? So we have create. Yeah. So in the previous class, we didn't mention creation, right? Database creation. We didn't mention that. Yeah. Yeah. But we have insert there. But here we don't have insert. Yeah. But we include the create action. Yeah. Yeah. So let me explain. So why it is the difference you see here. Yeah. Yeah. We want to include the create part. Yeah, it's important. Create new databases. Yeah. So we want to include that. Yeah. But why we skip insertion? So here you can see these 4. We skip the insertion operation. Yeah. Actually, we do not skip. Okay. Yeah. So my explanation here is insert, this action, insert, this action or action is included in this update action. So we use this one update action to represent 2 operations in our previous class: insert operation and update operation. 2. Okay? Yeah. Those 2 together, yeah. So we put in this update 1. Yeah. It's very common. So in our database related programming work, yeah, it's very common. We include, combine, insert, and update as one type. For example, here I use Java as example. Java database technology. Okay? Yeah. So when I use Java database technology. Yeah. So it's called a JDBC. So in Java, when we work on database, the basic part we call a JDBC. JDBC. Java database connectivity. Okay? Yeah, so the meaning is Java database connectivity technology. So that is the lowest level fundamental database technology used in Java. So fundamental. So this, yeah, why I mentioned this part is the fundamental part. Because there are many higher level database technologies. Yeah. But those higher level not fundamental. The higher level Java database technologies are built on top of this fundamental level. Okay? Yeah, built on top of this JDBC. Here we talk about fundamental level, JDBC. Okay? Yeah. Yeah. The bottom level. Yeah. In JDBC technology, so when we execute a query statement, okay? Yeah. So both insertion and update, so we use the same command, okay? So execute command, okay? Yeah. Yeah. So when we have a insert SQL command and update SQL command, so we use a SQL statement. represented. Okay? But when we do execution, the execute command called the execute update. Okay, execute update. That command, we can run both insertion and update. Okay, we can run both. Yeah. So those two cases, you know, we use the same command, execute update, same command, execute update, to do both insertion and update. So you can see it's quite common. So we combine insertion and update as the same type of operation under update. Okay? Yeah. All right. Yeah. Yeah. So then you won't ask that question. Okay? Yeah. With this understanding, so you won't ask, so why insert is missing here? Okay? Yeah. All right. Yeah, so I explained that insertion. Yeah. Then another property for the DBMS, general process software application. So any DBMS software is a general purpose software application. So what's the general purpose? Not specific purpose. General purpose, not special purpose. Okay, general purpose. Very general, that means inside DBMS, it only works on the general data. Okay? Yeah. So there is no, because the DBMS vendor, the company that produced the DBMS, we call it DBMS vendor. Okay? The vendor does not, sorry, I forgot to mute. Yeah. Interruption. Yeah. Sorry, yeah, I forgot. Yeah, mute. All right. Yeah. The general purpose software application. Yeah. So all the features are the general features. So they can be applied to any business. Yeah. But nothing is specific. Okay? The vendor does not know anything about anyone's business. Okay, so they cannot do anything special for specific, business things. Yeah. So here you can see that the general purpose requirement is good for any business. So any business can use that. Okay? Yeah. So another property of it does not rely on any business specifics. No. Yeah. It's not good. So if you connect it to any business specifics, then you have a lot of problem. Okay? Yeah. Yeah. So the vendor does not want to do that. Yeah. That supports all business. All right. Usually running on database servers, especially for large databases. Usually. So here I use this word, usually. So when you see this usually, yeah, so you know it's meaning most of the time, but not 100%. Not 100%. Okay? Usually, including the meaning not 100%. There is exceptions. There are some exceptions, okay? So most of the time, DBMS rely on database servers to power DBMS software. Okay? Yeah. So we know. So when you see this DBMS software, you know it's a based on your impression. So it's a pretty big software, right? Pretty big software. Yeah. So here, let me give you the idea a little bit. Okay? The size of the software. Okay? Yeah. The size of the software. Okay? For example, MySQL, MySQL. Yeah. Typically, several hundred megabytes. Okay? So, hundreds of megabytes. Yeah. Then Oracle, yeah. So another, important DBMS in industry, Oracle. Yeah. In gigabytes, yeah. A few gigabytes, okay, much larger than MySQL. Large. Okay? Yeah. All right. Yeah. Here you can see the DBMS software as large like that, several hundred megabytes or several gigabytes. You can only use database servers to power that large DBMS, right? Yeah. Yeah. So, yeah. Rely on database servers. Yeah. Yeah. So for large databases. Yeah. But there is exception. Here, I also want to talk about exception. Yeah. For small DBMS, sometimes very small DBMS. Okay? Yeah. For some small application, think about on mobile device. Mobile device. Yeah. So if you want to use databases in mobile device, you can imagine you cannot use very large DBMS. Okay? So we need to use small DBMS. So that's the exception case. We use embedded databases. Embedded. So there is a small database type called embedded. Embed in your application. Okay? Suppose we develop a mobile application. Okay? So that small mobile app, we need to use a lot of business data. Okay? Yeah. We need to do database queries in our mobile app. Yeah. And we want that app, mobile app, work. Even without internet connection, it can still work. Okay? Yeah. That means our mobile app does not rely on remote server, remote database server. Okay? If your mobile app uses some remote database server, then it relies on internet connection. If there is no internet connection, you cannot use the databases service, right? Yeah. But we know in many situations, people need to use the apps without internet connection. People still need to use some apps. So in that situation, we should use embedded databases. Okay? So in a small DBMS in our mobile apps. Okay? Yeah. Yeah. So the whole DBMS you copy inside your app code. Okay? Inside. Yeah. Your app code. So that DBMS cannot be very big. Yeah. Yeah. So there is a special type of DBMS like that. The size, here I can give a size. The size usually less than 1 megabyte. Okay? Several hundred KB. Okay? Yeah. So embedded. So usually the size could be, hundreds of KB. Hundreds of KB. Okay? Yeah. That small, that we can embed into our mobile apps easily. Yeah. And those DBMS, as small as like that, so they cannot use database servers. Okay? So what they use, powered by database engines. Okay? Yeah. A small engine inside. Okay? And you can do a lot of basic queries. Yeah. So all the basic queries, if it's not too complicated. Okay? Yeah. So most of our daily life business requirements, so we do not need too complicated queries. Okay? So we just need the basic, simple queries. Yeah. Then, so that small engine can handle easily. Okay? Handle easily. Yeah. So, yeah. Yeah. So you can see, yeah. That case contain basic functions. Yeah. But actually, it is very powerful. Yeah. So many web developers, when they develop web applications, many developers, they use embedded engine in their web applications because they feel it's already enough, good enough. They do not need to use a powerful, big data DBMS. No. So they do not need to use that big one. Yeah. Because most of their database queries, very basic. Yeah. Yeah. So those type embedded databases actually commonly used, also commonly used in many web developers, because they don't need a large DBMS. The small one already good enough for most of the web applications. So that's another way so that programmers use the embedded DBMS. Okay, all right, yeah. Yeah. So here, so give you the, overall information about DBMS. Yeah. All right. Work locally, yeah. Because you have an engine. You do not rely on outside resource. So in the package, inside your mobile app, so you'll have all the resources you need, everything you need inside that package folder. Okay, yeah, that's all you need. Yeah, yeah, yeah. So work locally. Yeah. Yeah. So then, without internet connection, any connection, so you can do the work. Okay, yeah. So a lot of functions, database queries, you can run. So that's another, real world situation you need to consider. Yeah. All right. Very sophisticated web building efficient algorithms and data structures. So this property related to the internal algorithms, efficient algorithms. Yeah. Because we know for typical database applications, the response time is very important. Response time, very important. Yeah. So how to make the database queries very fast? So in the DBMS programs, so you need to implement a lot of sophisticated algorithms to make the database query very, very fast. Yeah. So our module 5, in our module 5, we will talk about the main idea of those algorithms, because we cannot cover too much deep information in that module. So I just give you the high-level basic idea of those advanced algorithms. Yeah. So a lot of details, yeah, but we do not need to know all the details. Yeah. So we just want to learn the main ideas to help us understand how to make the database queries faster. Yeah. Yeah. Actually, the idea, although so many sophisticated algorithms, data structures, the data structure could also be very sophisticated. Okay? Yeah. Yeah. But the basic idea is very simple. Yeah. The basic idea is very simple. Basic idea is binary search. Yeah. You know the binary search. Yeah. So everyone here, because you have the algorithm background, right? Prerequisite algorithm class. Yeah. So you know the binary search well, right? Yeah. So in our module 5, almost all, yeah. So almost all, most part, yeah. 90% part, all 90% of those algorithms, fast search algorithms, are based on the binary search, built around the binary search. See? Yeah. So the binary search, very fundamental, related to efficient search. Right. So important, binary search. Okay, yeah. All right. More properties of DBMS. Yeah. Let me see how much time. Yeah. Not too much time. Yeah. Yeah. Anyway, yeah. So let's just complete this part. Yeah. All right. Built based on some database model. So here we go back to the, initial starting point of DBMS. Initial starting point. Model. So here I talk about the model for the DBMS. Yeah. Yeah. So what's that model? So logical structure of a database. Think about how did people create the first DBMS software? Yeah, so let's look at that question. Yeah. So long time ago, yeah, so people created the first DBMS software. So from there, yeah, they did a lot of work, right? A lot of sophisticated work. Yeah. So pretty hard. Yeah. Okay. Yeah. So, but when they start with some abstract model. So this model, abstract model, this description. You first you need to have some idea about the structure of a database. What structure? It could be very complicated, but when you start, you need to have some, in those people's mind, so they need to imagine some specific structure should be used in the DBMS to store the data, to store the data. Okay, yeah. So the model, logical structure of a database. So that detailed information should be provided in that model. Yeah. Yeah. So here, the DBMS we're talking about here, relational database model. Okay, so we talk about relational. Yeah. DB model. Okay? Yeah. All right. How to store, organize, and manipulate data. Okay? Yeah. So in the design, yeah. In the model, yeah. Model, we know high-level abstract. It's a very abstract, okay, description. High-level description, very abstract. Yeah. But how to store data, okay? Yeah. How to organize data, how to manipulate data. So all, those basic things should be described in the model, okay? Yeah. Yeah. So here, the relational model. Yeah. Yeah. All right. Yeah. So then, to manipulate the data, how to manipulate data? Yeah. Yeah. Some language, programming language, special programming language, special language should be used. Okay? Operations through standard language, the SQL language, SQL, structured query language. Yeah. Yeah. That special language must be designed, yeah, and should be available for a DBMS. Okay, yeah. So regarding the SQL, yeah. So currently, yeah, already dozens of years passed. Yeah. After industry adopted the DBMS software. Yeah. So regarding the SQL, there are two parts inside SQL. The SQL, big programming language, but inside it there are two parts. The first part we call the standard SQL. Standard SQL. Okay? So that part, that's really the standard. Standard means everyone using the relational DBMS must follow the standard, right? So, yeah. So, no exception. Yeah. So everyone must follow the standard rules in the standard SQL part. Okay? Yeah. So that's the first part. But the second part, non-standard. Yeah. The second part, called the extended SQL. Extension part. Extension. Okay? Yeah. So you can see from the name, the second part, standard part, not standard. Yeah. First, not standard. Okay? Yeah. So this one, not standard. Okay? Yeah. You know the meaning, then other people do not need to follow. Okay? Non-standard, you do not have to follow. You have freedom to choose how to do in this extended part. Okay? Yeah. Because we know there are many database vendors, right? Yeah. So in the market, yeah, in the DBMS market, there are many DBMS vendors. Many DBMS vendors. Yeah. So they have freedom to determine how to do the extended part, extended SQL. Okay? Yeah. As a result, yeah. Yeah. So here, usually we use MySQL and Oracle to do comparison. Okay? So in this class, we frequently use MySQL and Oracle. Although I do not give you a lot of details about Oracle. Yeah. So in my comparison, I mentioned the difference, yeah, between these two DBMSs. Yeah. Yeah. These two DBMS, they must have the same standard part. Yeah. Okay, no exception. Okay. But other than that standard part, for the extended part, these two DBMS, they are quite different. Yeah. Quite different. Yeah. Yeah. Because each vendor, although right now, MySQL is a product inside Oracle, inside the Oracle company, a product. So they acquired it. Yeah. So they have complete control on MySQL. Yeah. But they maintain the old way. Okay? So they maintain MySQL the original way. Okay? Yeah. Completely different, extended part. Yeah. So later, in many places, when I talk about query statements, we need to compare. So, a lot of differences. Today here, I do not the different part of the extended SQL. Yeah. Yeah. Here you only need to know many commands that work in MySQL may not work in Oracle. Okay? Yeah. So many commands that work in Oracle may not work in MySQL. The SQL commands may not work. Yeah. Yeah. So later I will give you some examples. Yeah. All right, so let me finish this slide. So we will pretty much finish the whole part. Data definition. How to define data? Data definition, so table definition. Okay? Yeah. Describe it in the model. Yeah. Data manipulation. So how to manipulate the data. Yeah. So the 4 basic operation. Yeah. Yeah. Also should be described in the model. Yeah. Data control. Yeah. So also want to put several levels, different levels of data control. Yeah. Grant privileges to specific users. Right? Yeah. So different users, they have different privileges to access different tables. Okay? So all those details should be specified in the model. So then, the programmers, so they can write the programs to implement all those requirements, specifications, and get a product, DBMS product, at the end. Okay? Yeah. All right. So we finished part of C. Okay? Yeah. Part of B, part of C. Yeah. Today we cannot start part D. So next time, so we will start part D from the beginning. Okay? Yeah. All right. So that's